Funding for this program is provided by Annenberg CPB to advance excellent teaching.
Why do we have different states of consciousness, from wakefulness to daydreaming to sleep? Are dreams the result of random bursts of electrical impulses deep within the brain? Or are they the product of hidden fears and desires? The mind, awake and asleep, this time on Discovering Psychology. Just as the earth alternates between light and darkness, all living creatures alternate between daily cycles of sleep and activity. The physical rhythms of nature, the daily rising and setting of the sun, the lunar month, the seasons of the year, are paralleled by biological rhythms in ourselves. Even plants show a daily cycle of changes in tempo every 24 hours. The circadian rhythm, from the Latin circa dies, about a day. This daily cycle of activity and rest is reflected in virtually every biological function. Body temperature, blood pressure, pulse, blood sugar levels, hormonal levels, all fluctuate systematically over the course of 24 hours. These internal shifts are reflected in fluctuations in our energy level, mood, and performance. And so each of us has a finely tuned biological clock, one which not only regulates bodily processes, but which also turns on and off our conscious contact with the world. Human consciousness, our awareness of the world and ourselves, is a constantly changing process. It ebbs and flows as inexorably as the ocean tides. Every day we experience a variety of alternate states of consciousness, from perceptions while we're wide awake to daydreaming fantasies, from reveries at the onset of sleep, known as the hypnagogic state, to sleeping and dreaming. Without consciousness, we couldn't survive, at least not for long. We wouldn't know about the world outside. In order to function, the mind constructs a set of working blueprints of the environment. These blueprints include some reasonable expectations, hunches, and predictions about what we're liable to find out there. Our consciousness enables us to read these blueprints and act accordingly and swiftly, helping to direct our behavior in adaptive and flexible ways, toward desirable goals and away from undesirable ones. The conscious part of our brain in the cerebral cortex also serves as an interior decorator. It tells us what things that enter our consciousness go together and how they should be arranged in our thinking. In other words, it imposes order on the objects and events we experience. The conscious part of the brain also takes on the role of dramatist. It strives to discover some coherent meaning in a storyline that knits together the elements in a way that makes sense to us. Normally, we're aware of only a small portion of what's happening in and around us. But much of what we perceive, know, and can do is not constrained by the narrow limits of our conscious awareness. Continual processing also takes place at non-conscious levels. Most of the physiological housekeeping of our bodies occurs automatically, so we don't have to think about breathing or blood flow or digestion unless something goes wrong. Most lower-level processing of sensory input is also non-conscious. Estimating distance and size of objects, recognizing patterns, detecting edges, and much more. Our brains are continually making complex computations that are essential for survival, and yet we're never aware of them. We only notice the end results. Learned skills which become routinized and automatic only need minimal awareness to carry them out. This routinization frees our consciousness to deal more with the new and less predictable. Everything, in other words, that isn't yet a stable fixture in our mind. As our consciousness works on this higher level, it does a number of things. It reduces the continual bombardment of sensory stimulation to only two categories: the relevant and noticed, and the irrelevant and ignored. Without this filter, we'd be overwhelmed by sensory data. Consciousness also empowers our mental processes to analyze, compare, and interpret whatever we've extracted from the stream of experience. And it enables us to respond flexibly to experiences by integrating what we know from the past, what we perceive in the present, and what we anticipate from the future. And finally, consciousness enables us to recognize our own mortality, because we have that awareness of past, present, and future. A mixed blessing, if ever there was one. Now, you might think that consciousness must have been of prime interest to psychologists throughout the history of the discipline. But in fact, scientific interest in this phenomenon has waxed and waned, just as consciousness does in our daily lives. And therein lies a major theme in the history of psychology. At the end of the 19th century, German psychologist Wilhelm Wundt explored the conscious thoughts and feelings of subjects in the hope of revealing the underlying structure of the human mind. Edward Titchener then carried on Wundt's work in the U.S. He too believed that psychology should concern itself with what's on your mind instead of the how and why it got there. This brand of psychology is known as structuralism. On the other side of the debate was William James, who regarded consciousness as essential for adapting to the environment. For James, consciousness was to be studied not in terms of its contents, but in terms of its function, from which his brand of psychology, functionalism, derives. In other words, what consciousness does for us. The first characteristic of consciousness that James specified is that it's personal and unique to each individual. It's also continuous and perpetually changing. And lastly, it's selective, choosing from the environment whatever is most relevant for the individual's adaptation. But in the 1920s, the famous behaviorist John B. Watson declared that consciousness was a scientifically worthless concept altogether. Only external behavior can be observed and studied, said Watson. It wasn't until the late 50s that the subject of consciousness was reintroduced by a new breed of cognitive psychologists. Today, psychologists are exploring consciousness in a number of different ways. One of their most fascinating subjects is how and why we pay attention to certain things and not others. Attention is the bridge across which information travels from the external world out there to the subjective world of consciousness in here. Attention is really a state of focused awareness. Whatever we pay attention to is processed and transformed from mere sensory signals extracted from the external world into perceptions, thoughts, and experiences. It's attention that serves as a selective filter which excludes much of the available stimuli that constantly bombard us. It reduces confusion and prevents what would otherwise be a massive sensory overload. British psychologist Donald Broadbent showed how attention works in an ingeniously simple experiment. Subjects were given headphones and asked to pay attention to either a story that was played into their right ear.
There was this little boy
or another different story that was being played simultaneously into their left ear. When tested later, the subjects could not remember anything about the story presented to the unattended ear. So attention has a limited capacity. Attention is also a selective filter. When the material in the unattended ear is our name, or has some personal significance, we do notice and remember it.
Happy birthday, Phil.
Sometimes, of course, it's hard to pay attention to anything. As any student sitting through a boring lecture can attest, your mind wanders, irrelevant thoughts surface, and images of other situations far removed from the present float into view. When that happens, you're in the midst of a daydream.
It's the bottom of the ninth, 2 out and 2 on. Nathan steps to the plate. He's 0 for 4 so far. It's been a rough day.
Daydreams reveal another unique feature of the mind, its ability to create inner private realities unconnected to the world around us.
First pitch. It's low and inside.
Contrary to popular belief, daydreaming is often good for us. It helps us overcome boredom, cope with problems, and be more creative. And it keeps our minds active and our brains operating efficiently when they would otherwise be understimulated. Sleep, on the other hand, helps us reduce stimulation. In fact, for years, psychologists weren't particularly interested in sleep because nothing seemed to be happening, except for the occasional dream. Even though we sleep for over a third of our lives, we knew little about it until a discovery in 1937. It was found that the brain is far more active during sleep than previously thought. Our brain waves change in form with the onset of sleep and continue to show systematic changes during the entire sleep cycle. Psychiatrist Ernest Hartman of Tufts University is an expert on sleep.
I think sleep has a restorative function and probably 2 restorative functions. One involving something like protein synthesis, which the whole body needs, and one involving restoration of brain processes, which our higher functions need. And the second function is the more interesting one. This function involves putting together new material from the day before with old material. It involves making connections in the brain. So I think Shakespeare put it beautifully when he said sleep knits up the raveled sleeve of care. You can kind of see the sleeve of care, some unraveled material, new stuff that you've learned the day before, it doesn't fit in, loose ends and so on at night. In the morning, sleep has done its thing, has pulled it all together, and you're in good shape. Your sleeve has been restored for the next day's wear.
Using electroencephalograph technology, or EEG, brainwave tracings made from sensors attached to the scalp and face, researchers since the early 50s have observed adults during night-long sleep sessions.